Hello students, today's video is on conditions of tangency on different conics, and I'm sure this video will help you to learn all formula in one shot as I have organized them in tabular form. So first of all, the line should be in slope intercept form, that is y is equal to mx plus c. Now my curve is circle. Its equation is x square plus y square is equal to r square with center 0, 0 and radius is here r. For this type of circle, the condition of tangency is c is equal to plus minus r root of 1 plus m square. We get c from the line, that is the y-intercept of the line, m is the slope of the line, and r is here radius. We put all the values here. C is slope intercept, y-intercept of the line, r is the radius, and m is here slope. So if this condition satisfies, then this line is tangent to this particular type of circle. Now, if this is condition of tangency, then replace the c of the slope intercept form by plus minus r root of 1 plus m square. So equation of tangent comes out to be y is equal to mx plus minus r root of 1 plus m square. And one more thing is written here, that is point of contact, and that also involves the sort of tangency there. Therefore, just you can substitute the values. The point of contact for this type of a circle, that means this line is touching the circle at this point, plus minus r m upon root of 1 plus m square, comma minus plus r upon root of 1 plus m square. So by putting the values, we get the point of contact. Now for the second type of circle, that is either your circle may be written as x square plus y square plus 2gx plus 2fy plus c equal to 0, where center is minus g minus f and radius is root of g square plus f square minus c, or that may have been written in the form x minus h whole square y minus k whole square is equal to r square. This is known as standard equation of the circle, and this is known as general equation of the circle. In this case, center is h comma k and radius is here r. Again, line should be in slope intercept form. If it is not, then convert it into slope intercept form. Now in this particular type of circle, the condition of tangency comes out to be c is equal to k minus mh, and rest is this same, that is plus minus r root of 1 plus m square. Just you have to add k minus mh. And how we obtain that? You can just change this equation of tangent. The equation of tangent in case the circle is having center at origin is y is equal to mx plus minus r root of 1 plus m square, or in other words, this is written as y minus 0 is equal to m into x minus 0 plus minus r root of 1 plus m square. But in case of this type of circle whose center is at h comma k, you just replace this y by y minus k and x by x minus h. And as you all know that c is the part which doesn't contain x and y. Therefore, in this type of equation, y is equal to mx, and we are left with, if I rewrite this, then this is y is equal to mx, and if I take k to this side, then in that case, this part works as our c. So this is how we obtained c here. So for the second type of a circle, condition of tangency is c is equal to k minus mh plus minus r root of 1 plus m square. And similarly, we can obtain the point of contact here. How? This in the previous type of circle where center is at origin, but in this circle center is hk. So just you replace the x coordinate by replacing h plus minus, add just h here, that is the x coordinate of the center, and for y coordinate add k. So this is how we get the point of contact when the circle is having center at h comma k. Now, next curve is here. My next conic is parabola. Again, line should be in slope intercept form, that is y is equal to mx plus c. If it is not, then convert it into that. And my first type of a parabola is here. Y square is equal to 4ax. For this type of parabola, condition of tangency is c is equal to a by m. So the equation of tangent comes out to be y is equal to mx. Just replace the c by a by m. So we get mx plus a by m. And the point of contact in this case is a upon m square comma 2a upon m. For the second type of parabola, whose equation is y square is equal to minus 4ax, line is y is equal to mx plus c, and here c is minus a by m. If it is plus here, so tangency also contains plus. If it is minus here we put minus sign. So this is what the condition of tangency for second type of parabola, and the equation of tangent comes out to be y is equal to mx minus a by m, and point of contact turned out to be minus a by m square comma 2a by m. Now for the third type of parabola, that is x square is equal to 4ay type, line is y is equal to mx plus c. Here c is minus am square. You have to keep in mind, if there is plus sign here, we put minus here. That's just opposite to the sign containing the parabola. Now, for equation of tangent, what we get, this turned out to be y is equal to mx minus am square, and point of contact here is 2am comma am square. For fourth type of parabola, that is x square is equal to minus 4ay, tangency has opposite sign, that is c is equal to plus am square, and the tangent is y is equal to mx plus am square, and the point of contact is here minus 2am comma minus am square. My next conic is ellipse. So for that, y is equal to mx plus c is line, and my ellipse is x square upon a square plus y square upon b square equal to 1. Here my c is root of a square m square plus b square. So tangent is y is equal to mx plus root of a square m square plus b square, and point of contact is here minus plus a square m upon root of a square m square plus b square, and comma plus minus b square upon root of a square m square plus b square, somewhat similar to the circle. For this was ellipse, and for hyperbola, most of the results we can convert by just replacing plus by minus, less by greater. So for hyperbola, that is the first type of hyperbola, which is also known as transverse hyperbola, which is along x-axis, symmetrical about x-axis. My tangency, just you have to replace this plus sign by minus. So in this case, my tangency is root of a square m square minus b square. Equation of tangent turned out to be y is equal to mx plus root of a square m square minus b square. And similarly, point of contact is plus minus a square m upon root of a square m square minus b square, comma plus minus b square upon root of a square m square minus b square. For the second type of hyperbola, which is also known as conjugate hyperbola, and which is along y-axis, equation of conjugate hyperbola is either written as x square upon a square minus y square upon b square equal to minus 1, or by y square by b square minus x square by a square equal to 1. Here the condition of tangency, you just flip the terms, flip these terms, and the tangency comes out to be root of b square minus a square m square. Similarly, tangent is y is equal to mx plus root of b square minus a square m square, and point of contact is here minus plus a square m upon root of b square minus a square m square, comma minus plus b square upon root of b square minus a square m square. So this is for conjugate hyperbola. And lastly, for the rectangular hyperbola, which we obtain by replacing a is equal to b, so this is along x-axis. So my equation is x square minus y square is equal to a square. And tangency, I'm just reducing this into rectangular. So my tangency is root of a square, sorry, this one, the first one, which is transverse. So my tangency is root of a square m square minus a square, and my tangent is y is equal to mx plus root of a square m square minus a square. Similarly, point of contact is plus minus a square m upon root of a square m square minus a square, comma plus minus a square root of a square m square minus a square. So this is the whole table about condition of tangency on different conics. Now what types of question we get? Now first question is like this. In this question, this line y is equal to 3x plus c is tangent to the circle x square plus y square minus 2x minus 4y minus 5 equal to 0. And you know that for this general equation of circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. My center is minus g minus f, and here my radius is root of g square plus h square f square minus c. And if I reduce this into standard forms, so this comes out to be x minus h whole square. This is known as standard equation. Y minus k whole square is equal to r square. Here my center is h comma k and radius is here r. So we just find the center. So if I compare this equation with the standard equation, my center is, I just replace 2g is equal to minus 2, so g comes out to be minus 1. Similarly, 2f is equal to minus 4 here. So in place of 2f, I have minus 4. So f is here minus 2. My center is minus g minus f. So my center is here 1 comma 2, which is h comma k. And radius is root of g square plus f square minus c. Therefore, my radius is here 1 square plus 4 and minus of minus 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 plus. So this comes out to be root 10. So my radius is root 10. And here I have h is equal to 1, k is equal to 2. Now, if this line touches this circle, that means if this line is tangent to this circle, so in that case, the condition of tangency should be satisfied. So for that, the tangency for this type of circle is, the condition of tangency for this type of circle is C is equal to k minus mh plus minus r root of 1 plus m square. So here I replace k by 2. M is what? The slope of the line, and line is here given to us y is equal to 3x plus c. So m is here 3 and c is here c. So in place of m, I write 3. In place of h, I write 1 plus minus r. Radius is here root of 10 and root of 1 plus 3 square, that is 9. So this comes out to be 2 minus 3 plus minus root 10 into root 10, that is minus 1 plus minus 10. So my c is minus 1 plus 10, that is c is equal to 9, and another value is minus 1 minus 10, that is c is equal to minus 1. So my correct option is, this is how we obtain the c, and for this question my answer is B option. That is, my C comes out to be 9 here. If I just satisfy the condition of tangency, that means if line touches the circle, then that must satisfy the condition of tangency. So this is one type of application. Now, few more applications are here, and this question was asked in 2014. Another application of condition of tangency, and that is what? In this particular question, we have to find the slope of the line which is touching both the parabolas. That means the slope of common tangent. We have to find the slope of common tangent. So for that, The first type of parabola, y square is equal to 4ax, is similar to y square is equal to 4ax type. So 4a is here 4. So my a comes out to be 1 here. Second parabola is x square is equal to minus 32y. So I just compare it with x square is equal to minus 4by type. So in this, minus 4b is equal to minus of 32. So b is here 8. In order to find the slope of common tangent, we just have to equate the condition of tangencies of both the curve. So for this particular question, the condition of tangency of first type of curve, that is y square is equal to 4ax, is c is equal to a by m. And for the fourth type of parabola, that is x square is equal to minus 4by, is c is equal to bm square. So for common tangent, we equate the tangencies to get the slope of the common tangent. Here my a is 1 and my b is 8. And on solving, what I get, if I take this 8 to left hand side, so this, and m to right hand side, so m cube is equal to 1 by 8 and m is here 1 by 2. So the required slope is half. So this is how we obtain the slope of common tangent. How? By just equating the condition of tangencies of both the curves. So my answer is 1 by 2. This is another application. Now few more applications are here, and this is, now in this particular question you have to find two common tangents to the circle x square plus y square is equal to 2a square and the parabola. For this case, x square plus y square is equal to 2a square is a circle with center 0, 0 and radius is here root 2a. And the second conic is y square is equal to 8ax. This is equivalent to y square is equal to 4. I just replace capital A here, type of parabola. So from here 4a is equal to 8a and capital A is equal to 2a. Now, in order to find the equation of common tangent, we let the equation of tangent, and I let the equation of tangent as y is equal to mx plus c, and I replace this c by condition of tangency of one of the conic. For circle, the condition of tangency is c is equal to plus minus r root of 1 plus m square. Here I have c is equal to plus minus root 2a root of 1 plus m square. For parabola, condition of tangency, for first type of parabola, condition of tangency is a by m. And if I replace this a by 2a, so my tangency is c is equal to 2a by m. So I let the common tangent as y is equal to mx plus c, and I replace this c by one of the condition of tangency. So I just substitute this from the parabola, that is 2a by m. Now I just have to find the value of slope, and how we obtain slope? By equating the condition of tangencies of the two curves. So one is circle and its condition of tangency is written here, that is this, and another is parabola, its condition of tangency is 2a by m. I just equate the condition of tangencies, that is root 2a root of 1 plus m square, and here I write 2am. Now next step is squaring. What I get, this comes out to be 2a square 1 plus m square. On RHS I get 4a square upon m square, and further solving I get this. If I take m square to the left hand side, I obtain this. My middle term split into 2m square minus of m square minus 2. Further solving, I get these two values of m square. One of the equation is m square plus 2 equal to 0, and another is m square plus 2 is equal to 0, and another is m square minus 1 equal to 0. From here, this is not possible because I get imaginary root, and from here I get m is equal to plus minus 1. Now what we have to do, we just have to substitute this value of slope in the equation of common tangent. And when I substitute in that, that means if I replace m in equation by 1 by plus minus 1, I get this as my equation of common tangent. I just substitute m equal to plus minus 1. And on further solving, if I take plus minus common, so my equation of common tangent comes out to be this. And my required answer and the correct option is here. So my correct option in this particular question is B option. So this is another application of condition of tangency. Now, look, in this particular question, we have to find the locus of point AB, which is moving under the condition that this line is tangent to this hyperbola. If this line is tangent to hyperbola, then this must satisfy the condition of tangency. Line is here, y is equal to alpha x plus beta, and if I compare it with y is equal to mx plus c, so in this case my m is alpha and c is here, m is here alpha and c is here beta, and the conic is here hyperbola, and that is x square upon a square minus y square upon b square equal to 1. If this line is tangent to this, that means in place of a square I have a square, in place of b square I have b square. And in conic, in this particular parabola, if this line touches this parabola, line is tangent to parabola, then this must satisfy the condition of tangency. And for this, the condition of tangency is c is equal to root of a square m square minus b square. So I replace c by beta, a square by a square, m by alpha, so alpha square, and b by b square. And on squaring, what I get, beta square is equal to alpha square a square minus b square. Since this question is of locus, that means you have to find the locus of the moving point p alpha comma beta. Therefore, ultimately we have to replace alpha by x and beta by y. So when I replace alpha by x and beta by y, I get this as the locus. And on further solving, if I take this to this side and this to y to this side, so my equation comes out to be like this. And this is what, again, a hyperbola. So the locus is here hyperbola. This is what equation of hyperbola. So by following the given condition and by satisfying the condition of tangency, because in this particular question the point moves in such a way that this line touches the hyperbola, so that means condition of tangency must be satisfied here. On following that condition, we obtain a curve, and that is hyperbola. So one more application of that table is this. And this question was asked in 2012. In this question, the tangent to the hyperbola is x square by 9 minus y square by 4 equal to 1. Our tangents are drawn to the hyperbola which are parallel to this line. And line is here 2x minus y equal to 1. Slope of this line is minus a by b, that is 2. And slope of tangent which is parallel to this above line is 2, because parallel lines have same slope. So here my m is 2, that is the slope of the tangent is 2, and you have to find the point of contact of the tangent on the hyperbola. So for that, we know that the point of contact for hyperbola is plus minus a square m upon root of a square m square minus b square comma plus minus b square upon root of a square m square minus b square. So I just replace the values. A square is here 9 and b square is here 4. So we just substitute these values. That means in place of a square, I write 9. M is here 2, so into 2 upon root of 9 into 4 minus 4. Similarly, y coordinate is b square, and b square in this is b square is a 4 upon root of 9 into 4 minus 4. On further solving, what we get, this is plus minus 9 into 2, and this comes out to be root of 32, which is 16 into 2, so that is 4 root 2, and here again 4 of root 2. So these are my point of contacts. So my correct option is here option A and option B. So this is how we use that table here. I hope this video will help you to learn very important concept of conic section. So please give a big thumbs up and share and subscribe my channel Math Advice. Thank you.